Hi everyone, this is the third video for section 2.1 on sets. So we're going to go through these examples. We're going to go through these examples. So the first one says to rewrite the following statements using mathematical symbols. So you can see with example 1, both A and B talking about being an element of a set or not an element of a set. So whenever we see, remember the element symbol looks like this, right? A C, and then you draw a line in the middle of it. So whenever you see this symbol, you should read it in your head as is an element of. So whenever you see that symbol E, you should read as is an element of, and that'll help us to translate from words to mathematical symbols and vice versa. So example 1A says that 0 is not an element of the null set. So we're going to have 0, and then we're going to write the element of symbol, but because 0 is not an element of the null set, we just put that line through it, and then the null set, which looks like that. So this is how you translate this phrase to mathematical symbols. But this is also something that is a true statement. So I'm just going to write that down, that this is a true statement. So this is one thing just to keep in mind with the empty set. Remember that the empty set has no elements. So nothing is an element of the null set. So although the cardinality, right, the number of elements in the null set is 0 because there's none, 0 itself is not an element of the null set. So that's just one thing that I wanted to point out, that even though there are 0 elements in the null set, 0 is not an element of the null set, just in case there's any confusion there. Okay, so B says 3 is an element of the set B. So we again write 3, we write our symbol is an element of, and then we have the set B, right? So remember, we denote sets by these capital letters. So this one, we don't know if it's true or false because we don't know what B is, and so therefore we cannot assess if 3 is an element of that set. But regardless, this is how you translate it to mathematical symbols. So you may notice that all of these English sentences have a period, right, to be a full and complete grammatical sentence, but you don't need to have that for these mathematical statements that we translate to. Okay, the second example, so now instead of dealing with being elements of a set, we deal with being subsets of a certain set. So again, just like the element symbol, so we're going to note that this subset symbol, we should read it as is a subset of. So right, this was just the normal subset symbol. We also have the proper subset symbol. So this is a proper subset of. But normally we're just going to use the subset symbol just because it includes the case where things could be equal, so it's just a safer thing to use. So let's do this first one. So we have the set D is not a subset of the set E. So we're going to start with the set D and then the subset symbol, but this says it's not a subset of the set E. So right, this just follows similarly to the one above it. D is not a subset of E. And the next one, we have A is a subset of the set U. So we have A, and then the subset symbol. Well, let me write that. We have A, and then the subset symbol, and then the set U. So A is a subset of U. Okay, so this is just how we translate between mathematical symbols and English sentences that we're given. Okay, so now, example 3, we are given some specific sets to look at. So U, our universal set, is going to be the set of all colors, all possible colors you can have. And we're going to look at this set S of these specific colors, the specific colors being red, orange, yellow, green, blue, and violet. And so now we want to compare these different things below. So in the first one, we want to see how S relates to U. So S is a set and U is a set. So that means we're going to be looking at the subset symbols. So we need to see if S is a subset of U or if it's not a subset of U. And because U is our universal set and S is a set of colors, well then we know that S is a subset of U. So you'll notice that these symbols that we have here, we don't distinguish between proper subset and subset. So this is just to kind of mirror what your homework will look like on WebAssign. It may or may not have the line denoting subset or proper subset. And so in that case, when you have homework that doesn't have both options, just pick one of them and it will be fine. Okay, the second one is relating red to U. So red is not a set, right? Red is a color. And so red can either be an element or not an element of the set U. So because red is a color, we know that red is in the set of all colors. Okay? So now, see, we have magenta in these brackets. So whenever you see that, you should read this as the set containing magenta. So you should read this as the set containing magenta, just so we don't read it as just magenta, because it's not just magenta. We have these curly brackets that are around it that tell us this is a set containing magenta. Let me fix this typo right here. So we have a set containing magenta. And so now we're comparing this set to the set U. So again, we're going to look at if it's a subset or not a subset. And so because magenta is a color, we have that the set containing magenta is a subset of the set of all colors, because magenta is a color. Okay, the last one right here, we are going to look at the set containing, so I'm just going to write it out again, the set containing green and blue, well, green and blue, and we're going to see how that compares to S. So because we're comparing two sets, again, we're looking at if it's a subset or if it's not a subset. So we want to see if green is in S, and if green is an element of S and blue is an element of S, then that means that the set containing green and blue is a subset of S, right? So this just follows from the definition of subset, that if it's in one of them, then it's in the other of them. It tells us that something is a subset. And we can see, based off how we defined S up here, that green and blue are in the set S. So the set containing green and blue is a subset of S. So one of these that, for example, would not be true is that the set, let me write it over here. So the set containing magenta this is not a subset of S, right? Because magenta is not one of the colors that's listed in our list notation of the set S. So it's not a subset of it. Okay, so now which of the following are true? The first one is S being a subset of U. So this is true, right? Just based on the definition of subset, that all of the elements of S, red, orange, yellow, green, blue, and violet, those are all colors. So they're all in the universal set U. So this is true. The second one, red is a subset of U. So in this case, red is an element, right? So red is a color, so it's an element of a set. So this is false, because we can't have an element be a subset. We need a set to be a subset. So what is true is that red is an element of U, because red is a color in our universal set. C, gray is an element of S. So this one, again, is false because whenever we look up here at our list of all the colors of S, red, orange, yellow, green, blue, and violet, gray isn't there. So that means that gray is not in that set because we listed out explicitly every element in the set S. And lastly, the set containing green and blue is a subset of S. So this one, just like before, is true because green and blue are elements of the set S. Okay, so these are examples just to kind of give you more of an idea of what questions concerning sets, subsets, and elements, and really just the difference between those, because there is a big difference between them, but sometimes it's hard to see it without doing a lot of examples and looking at things like that. Okay, now that is all for this video.